Hello all, welcome to our channel Where to Know. So in this video we will talk about a simple water level sensor circuit simulation. And before going to that circuit, if you see here, there are several types of water level sensor options available in the market. Like for example, if you see, this is a ultrasonic sensor type, and then we have PCB type. This has PCB traces, and then this basically is a mechanical reed switch type water level sensor. Okay, so and then ultrasonic sensor, which is HCSR504, which is an option. Okay, so these are all the options which are present if you are considering a water level sensor for your circuit. Okay, now considering this, if you want the cheapest option and if you want to integrate easily into your circuit, this particular sensor, which is a PCB based water level sensor, is the simplest option. Okay, so how to design this? Let us try to understand the circuit, how it works, and then we will simulate it and see the outputs accordingly. Okay, so first, before going to the simulation, if you see here, this is a simple these are simple PCB traces which are there, and these traces are actually connected to like alternately. One trace, the first trace, okay, is connected to the base of a BJT, and the second trace is connected through a resistor um, to a power supply, and then again the third trace is connected to BJT, and again fourth trace is connected through the same resistor to the power supply. So we will show the circuit, and once you water comes to this particular level, you see that these traces start having conductivity between them, and with some resistance, the resistor connects to the base of the BJT. Okay, and we see analog voltage. So basically this sensor is a analog type PCB water level sensor. You give supply, you give ground, and then you get a analog signal out of it. S stands for signal here. So if you see the simple circuit, it looks like this. Okay, there is a NPN transistor, and to the emitter terminal we have a resistor. So this resistor must be tunable based on your ADC input requirements of your microcontroller or whatever. And this is connected through some 47 ohms to a 5 volt supply. The collector also is connected to the 5 volts, and as we said, the traces, okay, forms a conductive path when water touches this. Okay, that will be a very high resistance path. So for now we actually indicated or simulated that as a 100K. Okay, now let us assume there is no uh, like path here. Okay, so in that case what we can do is just try to cut this. Okay, so this is the case. Okay, and let us try to simulate the circuit, and if you see the voltage across this resistor, you can see it is 92 nanovolts, which is very less. This 92 nanovolts is also due to the leakage across this transistor. So we have a voltage which is almost zero at this when there is no circuit. Okay, now let us take this circuit. Okay, and let us get back the resistor. Now this resistance is a case where water has come to a certain level. Okay, and there is a conducting path that is formed. Now in this case, let us try to simulate, and you can see here the output is around 725 millivolts. Okay, in case if you want to further change this, let us close the simulation window for just to understand that we have changed this. Let us change this to 75K. Okay, that means what we are doing is basically the resistance to the base we are reducing so that more current flows, and the collector current is decided by the base current based on the gain of this transistor, and that flows to the emitter, which is developing the voltage across this resistor, and this particular voltage is connected to the microcontroller. Okay, now let us try to simulate this. And if we probe the voltage here, you can see it is around 900 millivolts. Previously it was 725. So that means if we go to the previous circuit, if the water level as it goes on increasing, okay, we get a higher analog voltage here, and this analog voltage is being fed to the ADC of a microcontroller. For example, let us assume, okay, we have a 10-bit ADC. Okay, 10-bit ADC meant, um, so 10-bit ADC meant you have 2 power 1024 values. Okay, 2 power 10, which is 1024 values, which can be achieved. So each value, if you do 1 by 1024, it's around 0.9 millivolt, point, right? So or 900 microvolt. So you can have incremental values of approximately around 1 millivolt. Every 1 millivolt can be read by the microcontroller. Even if you consider a measurement error, at least a 5 to 10 millivolts of variation can easily be read. That means this particular ADC can work really well to sense the voltage or water level, and this PCB based water level sensor, as you can see, it's a very simple circuit and a very low cost circuit. Okay, uh, and this particular circuit can be easily implemented by a beginner as well. So this is how a PCB based water level sensor works. Please post if you have any questions. Please try by yourself and let us know if you have any questions. Thank